Hello viewers, in this tutorial session I'm going to show you how to troubleshoot packets traversing or meant to traverse file path thread defense using packet tracer and packet capture. In order to either use packet tracer or packet capture, you go to device management, that's from device management, and you have to go to the particular sensor or the particular managed device, or FTD in our own case, our managed device is FTD. So we go to the particular FTD, that's FTD3, and on the extreme right here I have troubleshooting icon. I'm going to click on that, and from there I'll click on advanced troubleshooting. Don't worry about this health alert, it's just because the interface has not been receiving traffic, so that's why we have this. Don't worry about that. Advanced troubleshooting. So now advanced troubleshooting, it has 4 tabs. The first one is file download. I'm still going to come back to that. I will show you what you can do with that. The next one is thread defense CLI, where we can type in some commands as if you're on the CLI. You can use ping, trace route, and show command. For example, can run the show interface IP brief command. I'll click on execute, and that's it. Can run the show route command. Whatever show command you want to run, you can run. I'll do show run. So whatever show command you want to run, you can always run that. And whatever ping, you can ping, run trace routes. So that's what the thread defense CLI is used for. And packet tracer. And one thing I'd like to mention here, packet tracer and packet capture can also be implemented via CLI. So you can run the command using your GUI, and you can also do that from the CLI. So I'll show you how to do it from both the GUI and the CLI. So in this video, we're going to start with packet tracer. So now I have this simple topology. So I have a host here, this host 10.10.20.100. So the host will go, it's on the inside segment of the firepower. So I now have a router here. The router IP address for this interface facing my FTD is 20.20.20.1. So we are going to, so that's what we use for demonstration. Try traffic going from this host to this router. It's traversing the file path thread defense. So that's that, and this is my host here, and I can confirm this is the IP address 10.10.20.100. So that's fine. So here, packet tracer, the packet type is TCP, and IP address, if it's IPv4, IPv6, or FQDN, the IP address is 10.10.20.100, and the host 2020.21. The ingress interface is going to be the inside interface. That's the ingress. The source port, I'll just use a random source port, 10,000, that's fine. The destination is, I can use www, or if it's not there, I can just type in 80. So that will be fine. So that's all. And for the output format, it can be summary, detailed, which will be more detailed, XML, which will be in XML format. And the output here also, we also have another output, maybe I should call it format also here, raw and tree. So I'll show you that also. Let's get the raw format first. So clicking on start now, let me click on this. Let me hide this form segment so that I can see my panel. Okay, from here, phase 1, just route lookup, resolve egress interface. Okay, the egress is the inside interface, but now it found next up, which is the internet router. That's the next up, and next up is 2020.21. That's by virtue of our routes. We have a default route pointing to 2020.21. I can show you that from here. So this is my device. Click on edit routing and static. So I have a default route pointing to this gateway. So we have our default route, that's fine. I have the route for my packet flow. And now the next phase here, access lists. As you can see here, permits inside host to outside using the service object group HTTP, and this is the rule ID. Now the access policy is ACP3. The layer 7 rule is HTTP. I'm going to show you that. If you go back to the device management, the access policy which we assign to our FTD is ACP3. That's the name. So let me access control policy. This is ACP3. I'll click on the edit icon. And I can further confirm that by clicking on policy assignment. So it's been assigned to FTD3. And the name of my access policy is ACP3, which we can see from here. The access policy name is ACP3. And the name of the access rule, which the flow is, the name of the access rule is HTTP. This is the access rule permitting this, our host inside those, to reach the internet router via HTTP. So the access rule name is HTTP, and you can see that from here, layer 7 rule HTTP. So this confirms the access control policy name. This confirms the access rule name. And this is the object. And this packet will be sent to SNOT for additional processing, where a verdict will be reached. Now, yes, it should be sent. It's going to be sent to SNOT engine because we have intrusion policy here. We have intrusion policy, sorry, here on this HTTP rule. We have intrusion policy attached to the access rule, which you can see from here. So that means that's what this is telling us, that we are still going through the SNOT engine. Although I'm permitting it here based on my access rule, but SNOT engine will still need to do some check. And the final verdict will be given by SNOT engine. So here, the next phase, we have connection, class map. We have a default class map on FTD. The class map, the default class one is being assigned to the global policy. That's a policy map. And we have it here, and we have this service policy, which is assigned to our FTD. So if you want to, you can run show run, or maybe show policy map, or show run policy map, and the rest like that. If you want to see the configuration by default, we have that configuration on the FTD. Show run class map. That's my class map. I can also do show class. Okay, I can do that show class map. Okay, but show run class map, that's that. And show run policy map. So this is the default policy map. You can see our policy map from here. So, and this is the TCP map being referenced by our rule, TCP map. And you can also do show service policy, and you can do show run service policy. These are service policy. So you can see all that from here. You can even take whatever configuration we have here also, the TCP map. So it's been permitted. It's been permitted by service policy, so that's fine. And the next phase 4, we have NAT. And let me show you my NAT configuration here. Policy, devices, under devices, I have NAT. And I'll edit the NAT. To confirm that policy assignment, you can see FTD3, that's our sensor. And we are eating, our traffic is eating this dynamic NAT. So, and this is it here. Any IP from this subnet coming from the inside and going to the outside. So the source of such of that traffic will be translated to the IP address of the outside interface of the egress interface, which is outside in our case. So that's what we have here. So my host IP address, the source port, that's 10,000, the source port I use for the packet tracer input command. So that's this IP will be translated to this IP as it's going outside. So there's that. So phase 5, that's NAT per session is being allowed. Phase 6 IP options, that's you have that in your IPv4 header. It's an optional flag. After phase 7 also NAT per session. Phase 8 also talking about IP option is being allowed through all these phases. Phase 9 flow creation, that means the session is created. There will be a session ID, which you have here, flow created with ID 959. And phase 10 now talks about external inspection, that is the SNOT application that's not inspect. And phase 11 is now giving us the SNOT verdict. So phase 11 and app ID service unknown, application unknown, firewall rule, and our firewall rule is HTTP, that's the access rule name, and it's been allowed by the access rule. SNOT ID is 0, network analysis policy ID is 1, IPS ID is 2, and the verdict is pass. SNOT verdict, pass packet, allow this packet. So I will go to the next phase again, which is still talking about route lookup, just like the phase 1. Route lookup to the outside, and the next phase, phase 13, adjacency lookup, next up an adjacency. That is telling us that next up MAC address is this. Oh, sorry about that. So, okay, now let me confirm this. The IP address of the next up is 20, that's internet router 20.20.20.1. That's the same IP we are going to. So this is the internet router. Show IP interface brief, that's 20.20.20.1. I will show interface fast ethernet 00, and you can see the MAC address here. That's it. So this is the next up MAC address, that's fine. And the result, as we can see, the connection is being allowed. So that's the result. So that's it. So if you want to see it in 3 formats, I'll click on this, I'll click on 3, so you see it in 3 formats. So that's just the same thing, just as you have it as separated in folders, which you can open one after the other and look through. So now I'll do same now via the CLI, and I'll do packet tracer input, and the input is going to be from inside because that's the source address, and it's going to be, I can use ICMP for the, okay, let me just use TCP also, just to match what we have on from the GUI. And the source will be 10.10.20.100. The source port, I'll use source port of 1000, and destination, and yep, destination will be 20.20.21, and that will be port 80, that's www. Can use www, and I'll press enter. So that's the same thing I have from here. Let me move to phase 1. Just the same thing I have on the GUI. That's what I'm having here. The phase 1, the route lookup, the phase 2, giving me the access control policy name, the access rule name, and telling me that it's been permitted. It's been allowed by the access rule. It's also telling me that the packet will be sent to SNOT for further processing. And this is the service policy, and it's been allowed. This is the NAT policy being allowed, NAT per session, IP option, NAT further IP option, flow creation, the flow is being created. Phase 10 talking about external inspection, and phase 11 showing us this not verdict on the traffic, and the rest like that. and it's been permitted. And let me quickly show you something. Let me go back to my access control policy. Access control policy, ACP3. I'm going to edit. So now I don't want to assign any IPS policy. I'm going to put none. I'm going to save. I'll click on save. I'll click on deploy. I'll deploy my change. So we have to wait for deployment to be completed. Okay, so 98%, that's fine. I'll run the packet tracer command again. And now, what I actually want to show you, now the new packet tracer output. So phase 1, as usual, phase 2, as usual. This packet will be sent to SNOT for additional processing where a verdict will be reached. Okay, that's fine. Phase 3, and we move on. What I want to show you is actually here. Now, external inspect. That means external inspection, SNOT inspect. Okay. But if you look here now, SNOT ID 0, network analysis policy ID 1, IPS ID 0. Why are we having this? Because I have removed IPS. If you look at the previous output, let me expand this box. Let me expand. Let me go to the previous output. You can see here we have IPS ID of 2 because we actually have an IPS attached to the access rule. So that's why we have IPS ID of 2. Because then we have this policy access intrusion. We have this intrusion policy assigned or attached to our device. So that's why. So now, and from the packet tracer output, it's been given ID of 2. As we can see from here, it's been given IPS ID of 2. Now, let's come down to the new output. As you can see from here, we have IPS ID of 1 because I have removed, let me quickly show you that again. I have removed IPS rule from that particular access rule. From this particular access rule, I have removed IPS. You can see IPS is no longer enabled. So that's why we have it to be 0 here. So, but here we still have network analysis policy ID, which is 1. Now, I believe you understand network analysis policy now. If you've watched my video, that's in the section fire pathway defense policy section. I explain network analysis and rest like that. If you click on advanced, you are going to see from here that we have a default network analysis policy. So by default, every traffic that comes through access control policy 3, that comes through ACP3, will also be subjected to this network analysis policy. So that's it, balance, security, and connectivity. So that's it here. So that's why from here we are seeing this network analysis policy. So this network analysis policy. So that's it. So that's it about packet tracer. And we can also test packet. This is my host PC 10.10.20.100. The packet tracer is telling us that the traffic will be permitted if 10.10.20.100 is going to 20.20.20.1 and the destination port is equivalent to 80. It should be permitted. Just as we can see now, it's being permitted. So that's it. So that's it about packet tracer on firepower threat defense. So thank you very much for watching. In the next video, I'm going to show you how to run packet capture on firepower threat defense. Thank you for viewing.